So in 5.1 and 5.2, we talked about when we had the same common, same denominator, right? In other words, when we were doing stuff like 7/3 minus 5/3, when we had the same denominator, right? And that was kind of easy because we would just, it was 3 and then you had 7 minus 5. Okay, and 7 minus 5 is 2. So your answer would be like this. So this is easy when you have the same denominator here, okay? All right. So now in 5.3, we're going to talk about when we have unlike denominators, when the denominators are not the same. In other words, if I have something like this, okay, the absolute way that does not happen, this does not happen like this, okay? Don't even try this. Okay, this doesn't work this way, right? Doesn't work this way, right? So if I wanted to do this, okay, the first thing I have to do is make these into same denominators, right? That's the very first step. So to find, so I have to find a number that works, okay? So if I did, I need to find what, so this is where I'm going to use the least common multiple, right? Least common multiple here. So the least common multiple here would be what? Be 12, right? Be 3 times 4, really. 3 times 4 would be 12. So I'm going to have to express both of these fractions in 12s, right? Because then I would have the same denominator, okay? So in order to make this 3 into 12, I multiplied the 3 by 4, which means that I have to multiply the top also by 4. So you're going to have 4 times 7 here, right? And over here, to go from 4 to 12, I had to multiply by 3. So since I multiplied this guy by 3, I have to multiply this guy also by 3. Right, so it's going to be 3. So it's going to look like this. So when I convert, I'm going to get 28 over 12. Over here, I'm going to have 15. Okay. So now I have common denominators. Now it becomes easy. So because it's all 12s here, so I have 28 minus 15, 13 over 12. Okay. And this is really it. This is it. This is it for the day. If you understood this, you understand what we need to do today. Okay? So again, the first step was to find the least common multiple. All right, we found that to be 12. And then you have to change the fractions. Okay? And then you do the addition or multiplication, I mean addition or subtraction or whatever you're doing. All right? All right. So let's see if we can do example number 1 in the book. Example number 1, I have 5 over 12 plus 1 over 3. Again, I do not have the same denominators. So I have to find the least common multiple of 3 and 12. Okay, so least common multiple would be what? What would the least common, Pastor, what would the least common multiple be? 12, right? It'd be 12. Okay, so it would be 12. So I didn't change this. It's already at 12s. I'm going to have to change this guy from 3 to 12. So I multiplied the bottom by 4 to get 12. So I have to multiply the top by 4 also. Okay. So I'm going to get 12 over 5, 12 over 4, 12 over 5 plus 4, 9 over 12. Am I done? Is there one more step that I can do? I can simplify it. Okay. How would I simplify these two? Grace?
From 3 over 6.
Okay, so it would be, I could do 3 over 4, right?
Yeah.
Because I'm going to divide by 3 here and divide by 3 on the top and bottom, right? So it'll be 3 over 4, right? Okay, so that'll be my final answer. Okay? Okay, B. B is negative 5 over 6, negative, is it 7 over 9? 7 over 9, okay. So now I have to find the least common multiple here, 6 and 9. What would that be? 18, okay, so it's 18. So if I multiply this guy by 3, I'm going to multiply this guy by 3, right? So it's going to be negative 15, right? Because it's negative here, right? 3 times 5 is 15. I'm going to have minus, I went from 9 to 18, so I multiply this by 2. And I have to multiply the top guy by 2 also. So it'll be 14. Negative 15, negative 19 over 18. So I'm going to get what? Negative 29 over 18. And we're done here. Okay. Now let's go ahead and see what would happen if I did the wrong, I found the wrong least common multiple. Okay. All right. Let's say that I didn't catch that was 18. And I'm going to think, yeah, question? Go ahead. So let's say I didn't catch it was 18, and I'm just going to say, well, it's going to be this times this. 6 times 9 being what? 54, okay? So let's say that I thought it was 54 instead of 18. So then I'm going to go 54, 54. So from here to here, I multiplied 9. Right, which means I have to multiply the top by 9 also, so it'll be negative 45. And over here, I went from 9 to 54. It's going to be, so I'm multiplying it by 6. Multiply the top by 6 also, 42. Okay, so I'm going to get 54 over minus 45 minus 42. 54 over minus 87. Right? Okay. So I got a different answer. But really I didn't. Because both of these numbers are divisible by 3. If I divide the top number by 3, I get negative 29. If I divide this guy by 3, I get 18. Okay? So even if you somehow get the wrong least common multiple, right, in the end, your answer should come out the same. Does that make sense? Now, if you did something like 16, then you're done, right? Because there really isn't no way to go from 6 to 16 or 9 to 16 or something like that, right? Okay, because at least this is a multiple of both of these numbers, correct? All right, at least, okay? Okay, so that's B. Flip the page, go to example number 2. Example number 2, adding mixed numbers. So I have negative 4, 2.5, plus negative 2, 6, and 11, is it? Okay, all right. So how are we going to do this? Any ideas?
Oh, 4 times 5
is
the 2.
Okay, so you're going to change this into a negative 22 over 5. Okay, all right. And then this guy here, I can do the same thing, right?
Yes.
So it's going to be plus negative 11. 2 times 11 is 22, plus that is 28. Okay, so we're adding a negative number. Okay, there's a plus and a minus, so it ends up being a minus, right? So I'm going to get 22, oops. Negative 22 over 5 minus 28 over 11. Okay. So what's my next step? Cooper, what's my next step?
You have to bring them both to the same number.
Okay, so I want I need the least common multiple. What is the least common multiple here? Lissandra?
Could we do 55?
55, right? Basically this times this, really, right?
Yeah.
Because there is no common factor here, right? So let's do 55. Okay, so go from 5 to 55. I have to multiply the top by 11. Okay. All right. And then the other one over here, I went from 11 to 55. I have to multiply this by 5. So I have to multiply this guy by 5. Right? So negative. Right? So if I add these two together, I get negative 382 over 55. And that's it. I don't think those are multivisible by anything else. Yeah, that's it. So you can leave it here. You can leave it here. You don't have to go any further, okay, in my room. Okay, you can leave it like that. You're done. Example number 3. How many more miles do you need to hike before you reach the next campsite on page 2? So let's go back to page 235. At the top, there was you were hiking between 2 campsites in Chesapeake and Ohio Canal National Historic Park. The distance between the campsite is 10 and 1/5 miles. I'm sorry, not meters. So I'm going from here to here, and it is 10 and 1/5. 1/5. 10 and 1/5. 100 miles, and you have already hiked 5 3/4. So I'm going from here to here, and I've hiked 5 3/4. So I want to find out how much is left. So in order to find that, number 3, you're obviously going to have to do what? You're going to have to take the total length, and you're going to have to subtract out how much you've already gone. That's what you're trying to do. Okay, so this becomes the same thing as we did before in example number 2. Okay, so Dino, how would I do this?
What was that?
How would you do this?
I am not sure.
And what did we do in example number 2?
I was talking to someone.
You were talking to someone. Okay, so we're going to have to take the mixed fraction and put it into a single fraction, right? So how are we going to change this? What is 10 and 1/5? Do you know?
10, no.
5 times 10 is? What is 5 times 10?
Hang on, brain.
AJ, what is 10 and 1/5?
50. It's 50.
51, right? Because we have to add the 1 here, right? It's 51?
50.
51 over.
Yes.
Okay. So over here, let's go ahead and do this one, the same thing over here, right? So 4, what do I get here? Do you know?
23 over 4.
23. Okay, so what's the next step? Now I have to make these into common denominators, right? I want the same number underneath here. What is this? What is the least common multiple?
1.
Huh? That would be the greatest common factor, not the least common multiple, right? Least common multiple will be 20. right? 4 times 5 is 20. So in order to go from 5 to 20, what did I do? I multiplied this by what?
4.
4. So that means I have to multiply the top by
4.
4 also, right? Good. That's 204. The bottom over here, I went from 4 to 20, so I multiplied it by 5, which means I have to multiply this guy by what?
5.
Okay, which is 115. Okay, so what do I get? I get 89. 89 over 20. So it's basically like 4 and 9/20ths, right? 4 and 9/20ths. Everybody get that? What do you see that? 4 and 9/20ths, right? So it's basically like almost like 4.5 miles left. All right. So that was example number 3. And then let's do example number 4. Example number 4. Oh, we have some variables in example number 4. Example number 4, I have so it's nothing different than what we had before. So I have to find first what? What do I have to find? Least common denominator. Okay, which would be 6. So 6. So I didn't change anything here, so this stays the same. To go from here to here, I multiplied it by 3. So I have to multiply the top by 3a. So 3a minus a is how many a's left? What?
0.
No? I had 3 a's, and I subtracted one of them away. So I'm going to have 2 a's left, right? Does that make sense? You get that? I had 3. I took one away, so I have 2 left. But then the 2 and the 6 can be simplified, right? To a over 3 if I divide top and bottom by 2. So that will be your final answer. Okay. With that, we are done.